All right. So in our previous videos, we looked at the frequency bar charts and some other different ways to represent data. And in this one, we're looking at a very useful one called the box and whisker plot. So without further ado, let's go ahead and jump right in. So the box and whisker plot is a really nice visual representation of data in terms of its dispersion. Because what we're given is basically we mark the maximum over here and the minimum over here at the very ends, as you might expect. And then they're connected to the box by whiskers. And then this line right here is going to be quartile 1. This line right here is going to be the median. This right here is going to be quartile 3. And then based off what we know about these, this is the interquartile range because it's Q3 minus Q1. And this is maximum minus minimum, so that's going to give us the range. So in a box and whisker plot, we're given the range, we're given quartiles, and the median, and it really is helpful. And always remember that 25% of the values are below quartile 1. 25% of the values lie between the first and second quartile because, again, the second quartile is the median, which is 50%. So if 50% lie below the median, 25% lie below quartile 1, well, then there must be 25% left over in between quartile 1 and the median. And the same thing goes between the median and the third quartile, also known as the upper quartile, and then 25% between the upper quartile and then the largest value. Okay? So those are some definitions and then what it looks like. But let's go ahead and take a look at an example and see how we can actually sort of create it. But before we start creating them, there is one other thing that I'd like to mention, which is that outliers can also be represented in box and whisker plots. And basically, if you take 1.5 and you multiply that by the interquartile range, if there is a value that is above quartile 3, when you multiply 1.5 times IQR, if that's above quartile 3, it's an outlier. And then if it's below quartile 1, it's an outlier in the minimum sense. So basically what you would have is kind of a minimum value here. But if you take 1.5 times the IQR and the distance is greater than that, well, then that's going to be an outlier on the lower end, and then it's going to be an outlier on the higher end if it is from that distance from quartile 1 to quartile 3, which might seem a little confusing. But basically, what you want to do is take the third quartile, and if you add on to that 1.5 times the IQR, if your value is greater than that, well, then you have an outlier. And if you take 1.5 times IQR, and then because we're going in the opposite direction, we're going the smaller direction, if you subtract that from quartile 1 and their value is smaller than that, you have an outlier. Okay, so very simple math, but it might just be a little bit confusing to remember, in which direction you're going in. So let's take a look at a data set to actually kind of help us out here. So let's say I'm looking at shoe sizes here. Okay, so I have shoe sizes, assuming this is European, 34, 36, 37, 38, blah, blah, blah. And I'm given how many males and females fit into those shoe sizes. So I'm going to go ahead and switch over to my calculator, as you should too. So go ahead and get out your N-Spire and follow along with this data set. So what we're going to do now is instead of running one variable statistics or two variable statistics or whatever, what we're actually going to do is we're going to click the add button, or in your case, add a pages, or whatever calculator you're using, and go ahead and get data and statistics. Data and statistics. So yours might look a little bit different, but the important thing is that we actually want to ignore this for now because, well, as you can see from the bottom and the left, we don't have any variables on this. So right now we can ignore this because what we actually want to do is we want to add another variable, because remember, we have frequency. I'm sorry. We have shoe sizes, but then we have frequency for males and females. So we have two different variables that we want to measure against the shoe size. So what we actually want to do is we want to hit plot properties and add an X variable. Okay, so let me go ahead and add an X variable, and I want to go ahead and add size. Okay, so now I have size on the bottom. So now that I've added size as my X variable, because again, that is what we are going to kind of see what the median shoe size is, what the first quartile shoe size is, blah, blah, blah. Size is going to be that X, that horizontal value. So now what we want to do is hit menu, and we want to go to plot type. And we want to make sure that we are selecting a box plot, which is also a box and whisker plot. So let's hit box plot. And there we go. Okay, now we're doing something. But what does this even mean? What does it actually tell us? So what we want to do now is hit menu again, and now we want to go to plot properties. So once we're now under plot properties, we want to now add a Y summary list. Okay, so let's add a Y summary list, and let's go ahead and select F. So now we added F, we also need to add M. So let's go ahead back to menu. Let's go to plot properties. Let's add a Y summary list again, and we're going to select M for male. So now we have a male box plot and then a female box plot. And what you can actually do here is move your cursor around to actually see what the values are. So if I wanted to know the median here, and I clicked it, I know that the median is 39. I would know that my Q1 is 38. I would see that my Q3 is 40. I would see that my maximum here is 42. But then I have a maximum way out over here. I can see that my outlier over here is going to be 49, and I can see that over here for in my female data, I don't have any outliers. My Q1 is 37, my median is 38 or Q2, my Q3 is 39, my maximum here is 40, my minimum over here is 34. Okay, great. Pretty tight dispersion, but that should go ahead and give you an idea of how to draw these box and whisker plots. And if you're ever required to do so on exam, you can actually just, create an X and Y scale and then kind of, make sure that you know what the minimum is, put that there, and then just kind of copy along the box and whisker plot so that you can draw it on a piece of paper. So I hope that helps shed a little bit of light into how we can use our graphing calculator to help us solve problems when we're given a table. And I promise once you actually do this a few times and get used to it, you will remember where the buttons are and you will make sure that you're not doing any kind of silly mistakes that'll kind of slow up the process of doing this. Okay, so hope you enjoyed the video and I'll see you all in the next one.